Good afternoon, everyone. Welcome back to the seventh session of Azure AI Engineer Associate AI 102 Bootcamp. I'm Vinayak Sharma, a core member of the Azure developer community, and I'm thrilled to be hosting today's session. Thank you all for being here for your active participation throughout this bootcamp journey. Your engagement and dedication are what make these sessions so valuable. Today's session is about implementing knowledge mining with Azure AI Search. We'll dive deep into how Azure AI Search helps turn raw data into meaningful insights, enabling businesses and developers to make data driven decisions. We are honored to have Sourav Bera with us today. Sourav is a solutions architect at Microsoft, and he comes with a wealth of experience in helping organizations build and optimize AI driven applications on Azure. His deep expertise in AI and cloud services will guide us through the intricacies of knowledge mining using Azure AI Search. Without further delay, let's dive into today's insightful session.
Hey Vinayak, how are you doing, man?
I'm good, sir.
So excited to be again as a part of this bootcamp series, and I hope everyone over here is having a really good learning time, learning on AI as well as the entire learning path, covering the entire learning path for AI 102. And I'm excited to see how many of you get turned into an AI 102 certified after this boot camp. So really excited again to reach back as well as talk to the audience over here, and really excited to talk about the session today. Yeah, so we can get started. I'll quickly share my screen, and there we go. So okay, uh 1 minute. So we have a very interesting topic today: knowledge mining with Azure OpenAI and Azure AI services. Well, okay. Do you think not? Do you know what is knowledge mining first of all? Do we really understand what is knowledge mining? And let's break this term into two. For sure, I would love to hear your perspective on what do you understand from knowledge mining. But I'm feel free to share it on the chat. But before that, I would like to give you a quick hint on this. Break this term into two different words: knowledge and mining, and just help me with some references onto what is exactly what do you mean by knowledge mining. So I'll be excited to hear your responses on chat. But just to give you a quick understanding, as we see, right, knowledge could be some sort of an information, some sort of a data, or some sort of an insights. And mining, as the word suggests, is to dig out or mine information from a whole set of data set, or it could be some document, or it could be some sort of an unstructured data. It could be anything, right? It could be structured, it could be unstructured, but to get the relevant or the important insights from some sort of a data is something that we usually term as knowledge mining. Now just imagine a scenario. Okay, you are given a textbook, and that is a textbook. And since most of us are from college, so let's give an example from the college. um, you're given a textbook, and just imagine the thick textbook for data structures and algorithm, and you need to identify the exact algorithm which is for a naive base, or maybe an algorithm that is used for a dynamic programming problem. And then you start identifying from the content that, hey, where is my topic, which is my dynamic programming. And within dynamic programming, then you'll move to that page. You'll try to identify what exactly algorithm fits into my specific use case or requirement. So in a term, that could be termed as knowledge mining. And again, this is a manual process, right? It could take us time if we are not acquainted with the structure of the book, or we don't really know what topic to go in and where to find the document. This is the exact problem or the scenario that we'll talk about in today's session. Without further ado, a quick intro to myself. So, for those of you who don't know me, my name is Sourav Bera, and I'm a solution architect at Microsoft. Apart from my day-to-day job, I'm also a community speaker. I love to interact with a lot of audience, so feel free to connect with me on the LinkedIn. You have the QR code, and you can scan that QR code to connect with me on LinkedIn. You can ask questions. You can reach me out for help or any sort of a demo that you require, or maybe I would be really happy to do so. I'm also a hackathon jury. I do love to participate in a lot of hackathons. Another period of time, the experience that I've gained, I do put in to, help out or mentor students or teams to hackathons. I'm also a researcher, something that I really love to do. So if you are in research or want to do a research in some or the other project, feel free to reach me out on LinkedIn or Instagram, and I would be super happy to share that with you. Apart from that, I'm also a Kubernetes Cube astronaut program member, which means this is a limited set of people across the globe who have deep expertise onto Kubernetes and have completed all of the Kubernetes certification. So, just a quick introduction about me that helps us get started. Well, well, now again, and I want to set the context. Since knowledge mining is a very advanced topic, maybe I'll want to break it up into two. And the idea for today's session is to give you a foolproof understanding, help you understand structures, help you understand architecture diagrams onto how knowledge mining is being planned, how it is being implemented at an organization level, and again, a very important point, knowledge mining is something that not as we as an individual would practice, or something that we really require, but imagine an enterprise, an organization, or any sort of a business that has tons of data. Okay, that is tons of data would ideally require or need the purpose of knowledge mining. So that gives a fair understanding that, hey, not individuals, but people, organizations, or a collective group of people who are dealing with a huge tons of data, they are the actual recipients of knowledge mining, and they would have tons of data, identifying the exact data which is important to them at a given point in time, and extracting that important information in the right form, maybe manipulating it to what is required, and finally putting it forward to the end user is something uh, that is the key requirement over here. So I'll show you certain use cases in this particular session, which will give us a quick understanding of how these solutions are implemented. And for sure, implementing these solutions at large scale would require a lot of dependencies, because you don't need those corps or data set. You need a certain amount of resources to be deployed for implementing these knowledge mining POCs or use cases. So the idea behind is to give you a walkthrough and understanding of how these knowledge mining solutions work. And I prepared some architecture diagrams that will act as a help for me to help you explain those as well. So before talking about knowledge mining, first let's understand the rate of adoption of AI in the current state. And every organization and every individuals on this globe are now working on AI. Either way, either they are leveraging AI or they are working on AI, but anyhow, you have to associate every task, every work that you do day in and out with AI. And otherwise, there are people who would also say that, hey, I don't want to use AI, but that's where you are losing out, because AI is like a solution or a tool that can help you increase your productivity. It can act as a co-pilot for you, right? You are the pilot, you are driving the plane, you are driving your task, and the AI acts as a co-pilot for you. So that's where just highlighting on few matrices on how enterprises are adopting AI and what is the level of acceleration that's happening in their forte is something that I wanted to highlight from this slide. So if you see, 95% of the enterprises understand how important AI is, and how important it is to adapt with the digital transformation with AI. And again, there are several instances, there are several case studies that are publicly available on internet, and you can see how organizations are leveraging the already inbuilt models to build in some really great use cases that can serve the society or maybe a particular use cases in the society. Now, again, uh, you see 80% of the organizations are working on AI and leveraging AI for some of the production workloads. Maybe a particular feature leveraging AI. Let me give you an example. So if you are aware, Mintra or Make My Trip has launched an AI. If you see on Mintra, so you will have that feature which will help you identify build, which will build an image, a 3D image, and help you try out apparels on that 3D image that is created for you. So you get to try those clothes virtually, right? That's something that's again AI is being leveraged over there. You also have in Make My Trip. I'll give you some examples that I just recently saw on the application, and these are something that are being enhanced over the period of time. Based on our findings, based on our search history, based on our collective decisions, it identifies how what are the usual choices or what is the usual taste of the customer. Based on that, it will recommend you future vacation options, future hotels, or let's say if I'm booking a flight, it will also suggest me hotels, so on and so forth. So these are something, these are very uh, I mean uh, very relevant use cases wherein AI is being used, and there's no limits to that, right? And again, 81% of the businesses are seeing positive ROIs of using AI. The investment that they make on AI, again, for enterprises, right? If there is a new technology, they have to invest on their resources to get them equipped on that technology, and then there is a lot of time and efforts on developing solutions on that tools or technology, right? So there's an investment that is there, and again, you see the ROI from those investments is something that businesses are really looking for. So 81% is a huge number on that. So if enterprise can, even we as an individual again can leverage those available models, build something on top of it, or let's say leverage those available tools that has been built on a certain model that is publicly available, and we can use it for our enhancing our productivity. On day to day life. Okay. So talked about how the adoption journey for customers have been on Azure on AI services, and it could be any of the AI services. It could be Gen AI, it could be traditional AI services, it could be some deep learning models, it could be some basic classic machine learning models, so on and so forth. Now, the key thing to understand over here is when we talk about even we'll come to knowledge mining, but before that, the key thing to understand over here is what are the different sections that businesses feel that, hey, here is something wherein we can potentially leverage AI, or what are the different segments within AI that organizations widely use or adopt. So first of all, the topic of today's session, knowledge mining, right? uh, when you say knowledge mining, just to reiterate, um, for organization, and I'm talking about in terms of enterprises, right? For enterprises, imagine they had run a survey for the public. Okay, they're running some application and they're collecting some survey information, or if there is an e-commerce platform, right, and there is a rating system. Do you think that the e-commerce platform would, again, those ratings are being stored, and the ratings and the comments are being stored in some sort of a database, right? But do you think they are individually going through those past data set and then collectively analyzing the rating, the total rating of the product, and then maybe featuring that product based on the rating on their product website? Well, no, right? That's not happen manually. So that's where again a knowledge mining, the concept of knowledge mining comes in, wherein you extract the important information, you understand the sentiment of the user who is writing that comment, based on the sentiment, based on the important information extracted. Let's say, give an example. This product has a really beautiful color, right? In that, maybe the beautiful color is some adjective that really helps me identify if it's a clothing apparel or something like that. If it's a electronic service, the durability of the service is a durability of the tool is really long, right? In that case, it helps identify if you see those keywords are being identified within the list of comments, right? So it helps us quickly get insights or the important insights which the organization or maybe some other customer intending to buy a product would be looking on. So that's where knowledge mining comes into the picture, and there are multiple other use cases. Conversational UI. Now, again, coming back to that e-commerce feature, and I'll be talking about e-commerce. I'll giving a lot of examples of e-commerce throughout the session, so just bear with me. So now imagine I have to buy something on Amazon or Flipkart. Okay, the most common examples. Now we gonna write something, and then there is some search engine that identifies get the catalog of the product. We'll also talk about this particular feature, how it works, and again, implementing this on a demo might not be that feasible, but again, I'll give you a high level understanding of how things work. So just imagine writing that product and then identifying that the search engine identifies a list or displays me a list of products. Among that catalog, I identify which is something that's important to me, right? And again, I go into the product reviews, ratings, identify that, hey, if this is something that I'm looking for, is this something that matches my standard? And if yes, then maybe I'll order that product. Imagine the entire thing being done by, by just placing your voice. Maybe I commanded, hey, Amazon, can you identify a grocery of this type of vegetables with this much of quantity and maybe with a minimum rating of this much from a seller, right? So, and it based on the insights that has been captured, it will automatically understand the sentiment in terms of what do I exactly mean, capture the insights, and get me the exact result, right? So this is something that's upcoming and it's still not being implemented, but in the e-commerce platform, I personally think this is something that will be there up very soon. Now talk about document process automation, third that we see over here. Can you think about some use cases of document process automation? Where do you require document process automation? Now imagine I'm a part of let's say some manufacturing enterprise. Okay, and I get a list of quotes from different contractors who are willing to work at my company on a contractual basis for a particular task. Let's say now, each of the contracts would have certain, quotes being presented with some sort of identification of what is the work that they are, they are, or the service that they are willing to provide, with the specific details on listings of the items that they will bring in, what are the requisites, so on and so forth, right? Now imagine this entire data needs to be fed into a database directly. That's the use case wherein an OCR comes into the picture, right? You can also think of a document process automation like this. Let's say government introduced a new scheme, and they collected some survey of information. That contains basically they rolled out a form, and individual people who wanna apply for that scheme um, filled up that form. Now, the government wants to perform a matching of the UID or the Aadhaar number to the form data that's been presented, so that they can map each of the scheme to the individual users who have applied to that scheme, right? This again means OCR for handwritten text, capturing that insight, and then maybe mapping it with the database, right? So you see over here, there is a combination of more than one AI services that are running. It could be OCR, it could be sentiment analysis, it could be OCR plus sentiment analysis, it could be OCR plus sentiment analysis, and then some generative AI to create insightful content or summary out of those information that is being extracted. So again, these are specific use cases, and there could be multiple models being used to achieve these use cases. So again, these are something that's complex, and we'll talk about it, how things are implemented at an enterprise level. Now, machine translation. Can you think about what is machine translation? Now, I'm looking on this chat again if there is any questions or anything that you have. Okay. I'm looking for answers on what do you think machine translation is. I'll just give one more minute for you to pop up with your answers, and then probably I'll discuss on this. Now, this is again a very great use case, right? Imagine the government rolled out a scheme. Okay, again, I'll give the same scenario. The government rolled out a scheme. There is something called as translation, and there's something called as transliteration. Okay, these are two different things. Now, machine translation, when we talk about, it's more advanced. It's more on the transliteration, and we'll talk about the difference between the two. Translation could be just mapping of a particular word or a sentence from a particular language to the other language, from English to Hindi, without understanding the sentiment of what that word means. Let's say, I want to drive a car. That will be itself converted as it is word to word into a sentence in Hindi or some other language. Again, the meaning of the word might change based on the form or the style of the sentence that has been created in the source language, right? So that's where the transliteration comes in. Understanding what is the sentiment or what is the meaning of the sentence that that the line makes, and then finally translating it to the equivalent the target language is what we mean by machine translation. Now imagine a great use case. Uh, think of a scenario. Government of India had launched a scheme. Okay, and ideally those schemes are either in English or in Hindi. Now, someone who is based out of some state, maybe West Bengal, Karnataka, Chennai, okay, and they are people from rural who really don't understand English or Hindi, or neither they have ability to read those languages. But I mean, for them, English or Hindi might be a foreign language, and they just want the document to the native language. Is there a way that we can, transliterate the entire document copy into the exact form and with the exact meaning to what is meant in the source language, right? So these are again a very great use case. Let me also cite an example. I'm pretty sure you have heard about a startup called as Bhashini, right? The key over there, the key use case or the USP of that startup is to convert or use Microsoft based AI models to convert one language to the other, which are again Indian local languages. In India, we have very diversified set of languages that we speak, and again converting these languages into each other is really can serve a great sort of use cases. Now the third is speech transcription and analytics. Imagine I am someone, I'm a VP of a company, and I am on to calls every day. Okay, I mean at every hour I have back to back calls, and every calls there are a lot of things being discussed. I don't have time to document everything or send out a summarized email of the meeting notes, right? That's where speech to text transcription is a very great use case. Now imagine this is something that is working, right? I mean, this is something that has been there in the market since long, but what is analytics on top of it? Now, do you think speech to text transcripts? when I speak in a mixed form of language. Let's give in a hypothetical situation. I speak English, but I also spell out some Hindi words as well in between. And that's where the speech to text translation might not work as efficiently as it would be in a complete English language conversation, in a dialogue, right? Now, this analytics tool is where it will identify, it will take up the raw text, it will try to understand what is the meaning of the entire conversation, and it will maybe prepare a summary. A very great use case that you see in today's world is your team's co-pilot, right? It will capture the transcripts. It will, very well take up the raw input. Now, this copilot will not only summarize what has been discussed, it will list out the action items that are left for the next meeting to upcome. Secondly, it will also identify that hey, this set of conversation was from Saurabh. So it's a multi log, or it could be a dialogue, right? Now over here, it identifies that hey, a user once spoke these many things. User two spoke these many things. Again, these are based on the voice recognition, right? So you see, there is speech text, there is some sort of a Gen AI, there is also voice recognition. So a combination of language models can serve a particular use case. That's what I wanted to highlight as a part of this tech. And you these are really great use cases. I mean, being from college, the key to put on these use cases over here is to give you an idea upon what is really trending, or what is something that's really important for organizations in the market. And if you make some really good projects over here in these use cases, maybe a chance of getting into similar roles in AI gets really increased. It's something that you should think about. Now, okay, okay. Now we'll come to the exact question of why knowledge mining. Again and again, we hunt for documents we urgently need, and it's nowhere to be found. We have more data than ever before, but we struggle to navigate to the right data at the right moment we need it. Imagine, I'll just give you a similar use case, and I'm pretty sure people who are working and who have a lot of data in their laptops might be facing this scenario. This happens on a day-to-day basis with me. Now imagine I have a lot of folders that I create within my C drive, and I have to identify a specific document from that specific folders that, and I might not know the exact destination folder in which the document might be resting right now. Imagine I have to use the search engine on my Windows Explorer to identify that specific document. It takes time, right? When it's a huge amount of data in GBs, it takes ideally a long time, right? And by the time I'm able to identify or get the exact location, it takes me, more than 5 minutes or so. So again, it could be as relatable as finding a particular sentence or particular insights from a book, which has a lot of many pages and what lot many sections, right? Again, uh, finding the exact insight, finding the knowledge is difficult. Let me give you one more example. Now you're given the same data such as an algorithm book. You're right into the second year, and this is your subject, right? You want to identify the exact content. You just not want to identify a particular content, but you want to summarize, or you want to gain the insights of the entire content of that book, right? um, Even that can be very time taking. It is again very difficult process as well. I mean, for people who really don't like to read books, right? So you want to extract those information. Again, when you talk about extracting that information, maybe you really don't want to also exclude very long stories of the stories that are being mentioned in the book, but you really want to extract the insights or the keys out of those stories, or whatever is whatever the author wants to convey out of the story that he presents in the book. You just want to gain those insights, right? You also don't want to include some miscellaneous data like acknowledgement, or some interfaces that are being present, some pages that are really not relevant to you onto that book, right? So these again could be something that you can relate with knowledge mining. Imagine in on an enterprise. Let me give an example. Okay, so if I am a VP and I've been given hundreds of presentations, documents, PDFs, so on and so forth each day, and I have to review each of them. Now, again, before approving anything, I need to go through each of them, and it's a very long process. It's ideally not possible for me to go through each of them, identify what is important, okay, and then maybe map it to what is required, or I mean, verify if that is something that's appropriate, and once appropriate, getting a sign off of that, right? So imagine some sort of an AI model, a combination of services does that for me. That will improve my productivity to a very great extent, right? Again, capturing the insights that I want. Let's say, give an example, right? I am the security officer, the chief security officer of a company, and I've been presented an architecture diagram of a solution. Now, do you think that that may be an entire report, an architecture diagram? It's just not about an architecture diagram, but it's an entire report, maybe of 50 pages. Do you think everything is important to me? I am keenly concerned about the security designs within that architecture. Or what are the security considerations that the team has inlaid before designing that application? So, if a model can get those insights for me, maybe my work gets optimized very much. I don't really have to traverse through the document, identify which section is something that's important to me, and finally get that, right? So again, for businesses, it's and these are very simple example going through a document. But imagine, I mean, you have tons of those documents, and you have to gain those insights each day. It becomes very difficult. It's almost next to impossible to pass through each of those documents. I mean, a very relevant example again. Knowledge mining could be also related to a great extent to the HR process, right? You are applying to a job, they receive tons of applications with tons of unstructured data. It could be structured, it could be unstructured, it could be anything. Just imagine a resume. It's an unstructured data, right? Now, for the HR, what is important? It is important for the HR to map the key requirements for a job description to what is mentioned in your resume. If the mapping happens, or if the keywords are matched, then I would ideally select that application to move forward to the interview phase, and so on and so forth, right? So these are where you would ideally think knowledge mining as a great use case. And again, it's not very limited. It's as wide as you can think. Now, I'll give you a very, you would say that, hey, sort of, I really already have these search solutions. If I have to identify a specific document or a volume within a library of solutions, I already have things available with me. But let me give you a very strong contrast. Let me take an example of a library search, book search engine, or let's say even the same Windows based search bar. Again, that's being improved, but again, just taking a very relevant example that you can, I mean, you can relate with the Windows search bar for a particular files or folders. Now, imagine you are in the root C drive and you want to understand or identify a particular exact file that might be existing within sub hierarchies of that Windows C drive, and you really don't know because there are tons of other folders. Now you just type in the name of the search button, and you really don't even remember the name of the exact file as well. You're trying to relate with some of the topic that's content of that file, right? And that's where you just type in and keep searching. Okay, you might not get the exact result. You might or might not, right? Because it does a word to word mapping of your the search or the keywords that you have provided in your search bar, and it tries to identify if that exists within the sub hierarchies or not. It can take a long time based on the amount of data that's there, right? Just imagine a Windows server, and that would have a file server system. It would have tons of files, folders, and sub hierarchies. It's almost impossible to find in that way. Now, when you talk about semantic search, now this is where AI comes in the picture. It's much more intelligent. How? Let's say A semantic search works in this form of model. It identifies the keywords. It tries to gain insights from the existing corps. When you say try to gain insights from the existing corp, it's basically trying to go through each of the files and folders. And this is something that being stored earlier when the model is trained on that particular corpus of data set. Okay, so it's already has insights identified, and it has a vector being assigned to each of the keywords that you have within that document, which is something that's important. Okay, now I would not have vector for each of the art. The articles like the so on and so forth. Only the relevant keywords. Okay, let's say there is a document known as um, final report for organization XYZ. So it will try to identify the keywords as report, organization XYZ, something like that. So now these keywords are stored in a vector database. And when you search for that particular keyword, either it could be the same keyword or even if it's a synonym of that, the semantic search has the ability to identify and understand the sentiment, or I would say this, identify a similar keyword, and it searches on the database. It will get you the result. Even just imagine, if you are in a library and that's a library book searching engine, you want to specifically identify a, you know that, hey, you want to identify a particular topic within that book, and you really don't know the name of the book. You just identify, you just search by a particular topic within that content, right? A traditional search engine or keyword search based engine would not work really there. If there is a semantic search, it would have already created a vector database that would have those stored contents of what is the content of that book or the volume, and it will fetch the exact volume that you require, right? And again, these are very great use cases for very huge amount of data, or wherein the data type is unstructured, right? Just imagine if it would have been a structured data set, just a keyword search would be very relevant in that scenario. And again, it depends on use cases to use cases. Even keyword search engine would fail when it's a very huge amount of data set with sparse data, right? The data is not very contagious, it's sparse data. Now, the problem three, finding knowledge is difficult, right? Managing most experienced enterprise search services requires dedicated resource and specialized expertise. Now, I talked about developing this sort of semantic search, right? What are the technologies, what are the type of AI models that you think would be required? And it's just not about these AI models, but also storing that data into a vector database. Now, why do we not require some sort of a MongoDB, a SQL DB to store that data? Why are we required to store it in a vector database? That's where the performance or how the latency of that search engine is very critical, right? Imagine you have to get a particular insight from the Google search bar, and the Google search bar or the search engine fetches the entire internet, right? And it just imagine it takes 5 minutes to just get a single search. It is very tedious. It's very, cumbersome as well. Again, right? So in that case, identifying the specialized workloads, the dedicated infrastructure that will run your models, again, the compute, the network, the storage is really very important. If you talk about storage, what sort of a storage services are you using? What is the performance related to that storage service? Now, talking about the data within, that's one level deeper. Talking about data that's being stored in that database or the storage. Okay. Storage, when I say, it could be some storage media. Do you think media would be stored directly in form of a document in the storage service? Well, no. Like, again, there would be some sort of vector being assigned to that media, and that vector would be linked to the data in the vector database. So this is how interlinking happens between the semantic search engines, right? There is a lot of interlinking. So identifying how these data is being stored, how's the retrieval process. Let's say if I have already the context or what needs to be identified, what is the retrieval process of the data, is something that is really important. And again, from the search bar I talked about, right, a keyword based search, so it will just try to map those keywords. When it's a semantic search, you would also have NLP, you would also have natural language processing, you would also have an analysis of the text that you are putting in. It will try to identify what sort of a data that you are putting in. Even if you don't have the exact keyword, it will try to find relevant data in and around that synonym. Okay, words. So this is how the entire semantic search would work. So I think you got a fair idea of what are the problems that the current enterprises are dealing with, and that is where the knowledge mining comes in. Now, I want you to quickly, in your words, state what do you think really is knowledge mining, and what are the services that you think, just mention as a particular use case, and what are the AI services that you think. And again, I'm pretty sure that you have came across almost all of the AI services till date. I mean, it's a seventh session of the boot camp, so you're aware about what are the AI services that Azure provides. Now you I want you to think broadly and state what are the AI services that you think would be required to achieve your specific use case, and just be very broad while thinking about a particular use case. Think as broad as you can. It could be as like identifying a particular route between two destinations, between a source and a destination, in a very huge amount of cursor data that contains different locations and different routes that are available. I mean, just like a Google map, right? How Google Maps work. So you can think about a variety of other use cases wherein knowledge mining really would work. Think of an attendance system. The camera gets the raw feed of the face input. Now there is a face recognition system that identifies the human. Now, do you think knowledge mining again comes into the picture? Well, yes, right? You would have a huge amount of student database. Now, identifying that student from that student database, mapping the relevant insights, getting that relevant insight, and maybe performing some other operations on top of it would again require knowledge insights, gaining that, pulling out that data or insights from a huge amount of course data set. And it could be also unstructured data. Just imagine I have a mark sheet of a student being placed in front of the camera, and it captures the feed or the image, and that from that document we capture some keywords and insights using OCR. Now that intelligent OCR should feed this data to some GenAI models, or some, let's say it needs to be fed into a database is performing some sort of an action, and then it gets the total some sort of data of the performance of the entire school, or maybe the entire class. Okay, uh, of class 10, something like that, right? So just think broadly of your use cases, and what are the AI services that you can you think it would be required to implement that knowledge mining solution. I'll give you a minute before we talk about the exact use cases that we gonna cover for today's session, and I'm interested to see them on the chat, so feel free to just ping in. Okay. I see a couple of questions as well. Vinayak, would you like to take some questions right now? Meanwhile, people think about their use cases.
So there are many questions in the chat.
Would you like to take some of them?
Sure, sir. So first question was asked by Muli. I wanted to know if how can Azure AI services help me in requirement engineering? Like if I want to go in that field, I want to take user requirements and something like that. So how can Azure AI services help me with that?
Well, that's again a great use case. Now, requirement engineering, right? You think about, and I'll give a very great use case. Let's say you are a consultant. Okay, you are into a customer call. You captured the insights, whatever was the requirement. Okay, or let's say let's take that example first. Okay, so you're capturing that insights, and how do you ideally capture it? So basically in a meeting format, and you have a transcription feature that captures the summary. Now the transcription feature would contain a lot of fillers. It would contain a lot of bloody statements again, which does not really make sense. Then you would have some sort of a model that will capture the summarized insights or the actual insights from the meeting. It will map those insights, or extract those instances of relevant information and make it as an actionable item, right? Now what, that is a part of it. That's something that still is available readily via Copilot, Teams Copilot, right? Now what do you think would be a one step ahead of that? Now, can you use those actionable insights to prepare a program of action or a plan on how would you execute that? That requirement to an to a exact MVP or an entire production instance, right? What are the key prerequisites that are required? What are the tools that are required? What are the resource efforts that are required to implement that solution? What are the technicalities in terms of the implementing that solution? What are the technicalities that are required? So on and so forth. Now again, one more great instance. Okay, and since I have been on that part, so I can very much relate to this particular use case. So imagine I am a customer. I'm working with a consultant. That's fine. But from my side, I really don't want to share this. This is very confidential to me. But I really don't want to. Have a third party capturing my insights. But is there a way that I can build upon my requirement so that this can be moved to my dev team rather than somebody else as a consultant capturing this insight and presenting it to the dev team? Can I build on a structure of requirement and present this to the team? Okay, so in this case, basically you and this is something that you can still try out. Just try out going to the Bing Copilot or Chat GPT or any other Gen AI based feature. Try putting in that, hey, you are a technical consultant. Try to prompt it like this: you are a technical consultant. You have to scope out entire plan or a program of action to implement so and so feature. Okay, and the requirement is this. So when you provide these prompts, be very concise, be very concise in terms of not adding much fillers, but also try to put in as much information or details about your application that you want. Now obviously you'll not get the exact answer in the first instance, but you have to reiterate, ask Copilot to make it better, add a detailed plan on timelines on how this needs to be implemented, what are the resource efforts that is required. um, will If this is going to production, is there any bottleneck that we might face into the implementing this feature, or when it's in production, what sort of performance issue it can face? You can query it. You can also ask which platform to use, right? So again, each GPT models might have some sort of biasness, but it will provide a comparison for me as a customer. If I have to implement, there are three vendors, and I have to implement one of the solution from each of the vendors. Okay, I want to perform a comparison. Do you really think I'll go to the internet, I'll search for feature comparison for each of the vendors? That is something Copilot can do for me, right? So again, this is a really great use case wherein you can use Azure AI services as well as knowledge mining to a great extent to capture insights.
Thank you so much for this, sir. Uh, the next question is asked by Akshaj. It is, can you give a high-level review overview of Azure AI Search? How does it fit within Azure AI Suite?
Sure. This particular knowledge mining that we are talking about, we'll talk in this part of the conversation when we are actually into the architecture diagram. We'll talk about how AI search comes in the picture. Now, let me give you a very simple example to understand. Okay, you have a document intelligence. We had talked in the last session about document intelligence. Now you imagine from that document you already extracted the key value pairs. Okay, that's something that's available with you. Now, can you store that data into a sort of a database? Okay, and it could be any database. And can a service or a engine that can pull out the relevant data based on the NLP based queries that you ask. Like, and then when I say an NLP based query, it could not be one to one mapping of answers. Imagine a chatbot, okay, that contains all the information of a website. That is the chatbot linked to that website. Okay, now that ideally a traditional chatbot would do what? It would basically take the query. Now, for that query, it will try to understand the requirement, okay, whatever is the ask, and it will provide a same sort of a one-to-one mapped answers, right? If it does not have that answer, it will say that I cannot help with this thing. This was something that we used to see, in the traditional chatbots. Now, with the Gen AI AI search, again, AI search is a part of that, okay? So, Gen AI comes later onto the chatbot feature. First of all, there is an AI search that identifies or pulls in the relevant data, brings that relevant data, and this data is now being fed to the generative AI model, which summarizes or presents the data into an actionable format, or into a format that is insightful to the user. And that's something that you see in the chatbots. So if you just go to any of the relevant airlines today, and you just ask that, hey, I want to see the flights from this source to this destination, you will see that the content that it brings out is in a form of a very human readable format, right? When you say human readable format, it will also pull in additional insights on this flight is something that's convenient to these sort of a users, or maybe this sort of a group of people, so on and so forth. So how does this come? So there is an AI search engine that's pulling in the data, and then there's Gen AI that is again improvising that answer and finally presenting it to the end user. AI search, giving one more example. Okay, so an OCR based engine, government capturing a survey, an OCR based engine capturing the key value pairs. Okay, okay, this was the document intelligence thing, the same thing, right? And then you have a vector database wherein the AI search engine is pulling in the data. Think about one more example. Uh, okay, now I'm into interview or podcast. A transcription feature is continuously capturing my data. You want to query that data and identify a relevant part of it. Or imagine you are just seeing a YouTube video, you get a summary of the data, some sort of a transcript, and then you want to just identify the relevant. You query a particular question, and based on that, you want to find the relevant information. That could again be a AI search engine based use case, wherein it identifies and puts in a vector, a vector hash to each of the relevant insights, and it based on your search query, it provides you the relevant insights. Yeah.
So there's one more question for now. Sohani was asking, what are the primary use cases for knowledge mining in organizations?
Sonia, I'll answer your question in just the next part of the slide. So that's upcoming for you. So great, and I see a very great example. Use case that's Unnati Agarwal has mentioned. So again, customer feedback analysis for businesses. So kudos, Unnati. This is again a great use case, and would love to see on how do you approach to implement this solution. Think about how you would also implement, and you did mention about the AI services that you require to implement this. Just try thinking about solution on this, and we'll discuss upon how organizations have their use cases, how they think about an idea or implementing that idea, and finally how that idea of the solution looks, in the next part of the discussion. So stay tuned. I'll just quickly move to my slides and
Yes,
discuss
sir.
this.
We
Okay.
can move ahead for now.
Sure. Okay. So now we have a fair understanding of knowledge mining, right? And where's my pointer? Now we have a fair understanding of what knowledge mining is, how it works, so on and so forth. How it works is something that we'll discuss in this. But somebody was asking, right? What are the use cases of knowledge mining? That's where we are over here. Now, again, I have presented you with only three use cases of knowledge mining, and this is what I thought could be a great use cases to scope out for this particular session. While trust me, use cases on knowledge mining can be as vast as you can think about it. Okay, so what we will talk about is one is content search. Imagine I have a huge amount of data. Imagine I'm running the search engine and a search engine. Okay, and there is a huge amount of data on the internet. Every day there is new data being added. Now, how will my search engine be able to pull the relevant data out of my search? That is something that we'll understand today. For organizations, I'll give you one more example. Okay, so for organizations, and I mean, when you, if you are working professionally, you would relate. So there is something that's available by Microsoft again, which is called as search for your work content. Okay, something that is relevant to you when you search. So either you have an open web based search or you have a work based search. So when you do a work based search, you get relevant resources from your organization's library or the organization's repositories based on your search. And again, there are a lot of nuances onto this. Do you think my organization, okay, I'm running a startup, and that startup, in that startup I would have a OneDrive or a cloud based drive or a storage service. Okay, now you think in that OneDrive will I will store obviously everything, right? But in my startup I have a solution architect, I have a CTO, I have I have a chief security officer, I would also have some developers. Now a question to you is that, do you think me being a CTO or somebody else being a solution architect and somebody else being a developer all would have the similar, um, level of access to those repositories? Well, no, right? A developer would only need product related or whatever features are there in the pipeline or level data. Even a solution architect would also have product level insights or access to product level documents, but also with some additional insights on what are the business priorities, how things are going, what is the plan of action, what is the upcoming project, so on and so forth, right? As a CTO, I would have a majority, a subset of data. I mean, major subset of the documents access, wherein it could be something which is related to the technical, which is development, something related to the product, something related to also the HR and new hirings. Okay, something also related to the sales of the organization, something related to the new strategies that the organization is planning, right? Now, imagine if this content search also provides, based on my search query, it also pulls in all of the data. This is not something that I want, right? It should only pull up data that I have access to within my organization. So if I'm a developer, so I should get only data which is relevant to my role. Now, again, knowledge mining is very intelligent enough and should have. I mean, the use case of knowledge mining in industries or enterprises are built in keeping in that in mind. Okay, so when you talk about content search, it's more about providing the relevant information, also ensuring that the user is entitled to see that information. Number one. Okay, also the knowledge mining model should also be very intelligent enough to identify that, hey, this is something that is not something that abides with the organizational guidance. Let me give an example. My repository would have a lot of code files, something a lot of other files as well. Now there was also one file which is called as api.key, which will have my API keys. Now, do I really want GitHub Copilot or my work search engine to pull in the data or the API keys to the users and expose it? Well, no, right? I don't really want that keys to be exposed. So my knowledge mining engine should also be very intelligent enough to identify what sort of a data needs to be presented to the user and what sort of data needs to be barred in or needs to be put isn't. It's not something that the content knowledge mining engine or the content search engine should really parse or go through. Even I don't want my model to parse that data, right? That's very confidential to me. So API keys is something that I really don't want to. Anyone who has access can misuse it. talking about document intelligence, right? I give you a lot of use cases. I mean, imagine I'm a startup and I have a new product release. Now, I captured a release a survey and I captured a lot of tons of information, and those could be handwritten. It could be digital. It could be of any form. Okay, it could imagine if it's a handwritten, it could be in several different languages as well. Now, how do I build a corpus of data out of this survey that I captured? Should I have a resource to individually, I mean, enter these data into a database? Well, no, that's not possible. That's something that we did in a traditional, I mean, old school way, right? Now it's the generation and where everything is automated via AI. So there's something called as OCR that will extract the data, and again, the data that's in handwritten format in a given language or maybe in multiple languages needs to be extracted. It needs to be translated and being stored in a common language that can be passed by the AI machine or the AI engine. Now think about catalog search, the third in the category. 1 minute. Now what is catalog search? Imagine you are in Amazon, right? And I really don't know about the product that I want to search in. Just give it a try, and that really works. Okay, I want to purchase a backpack. Okay, or let's say I want to search. I want to really purchase um, maybe a kettle. Okay, and I really don't have the context or the exact keyword to identify. I just type in water heater. That's again a very generic query, right? A water heater could be a geyser, it could be a kettle, it could be anything else as well. Now, I mean, identifying the users, the query, driving the insights, and finally getting the data or the product which is relevant to the user is something that the catalog search helps us. And imagine if it's a very small application, even a keyword based search would also work. But if it's a huge amount of data that is being stored in that application, like Amazon, Flipkart, so on and so forth, with a lot of product offerings, there are also products within the same category, multiple products by multiple retailers within the same category. Now, how do you also rank those products, present them into to the user when they search? Is all something that's being handled by the catalog search. Now, let's not dive into. I mean, let's not spend more time over here and dive into the exact implementation of these tools. Okay. Now, I talked about knowledge mining with Azure Cognitive Services, right? This is something that really helps you. Imagine I am someone who is not very well versed with the AI models, or as an individual or as a startup, I really don't have that huge amount of data to train an OCR model or to build a transliteration or multi-local Indian languages transliteration model, or I do not have the relevant uh, corpus of data to build a model that can identify the sentiment of other perform a semantic search based on the user query, right? Now, this is something that the Azure Cognitive Search or the suite of services that Azure AI services provide can be leveraged by organizations, by individuals to build on their MVP or production solutions. And as an individual as well, it's a very great tool that suite of tools that you can use to build on your personal projects. And imagine if you build some sort of these sort of projects, how great value does it add to your profile? So something that I really encourage you to do so. These are services or models that are really readily available to you. There are documentation on how to use these models. You can try combine these models into and serve a great use case, right? So, and again, we talked, if you remember, during the document intelligence call, we also had discussed how we can build our own customized model. We can also customize an existing trained model to serve our particular use case, right? And again, that is a very effortless process. Why? Even with this very small data set, as low as 5 images, you can train another OCR based model to serve your use case, or a different document intelligence model, right? So these becomes very easier for you. You must have heard about uh, teachtrainables.ai or something like that, right? That again is a no code based model training interface for computer vision based models or audio based models, so on and so forth. So again, those become, I mean, these tools becomes very easy for anyone who is not that experienced on AI, or somebody who really does not have the technical expertise to build a model for themselves. And another feature is that since these models that you customize are already being trained, retrained on a pre-trained model. Okay, so basically you're performing a feature training or a feature engineering on top of an already trained model. So it's the accuracy is also very high over here in this case. Okay, let me share a quick comparison of the how AI can make search intelligent. Okay, or the how does semantic search comes into the picture. Now, imagine the traditional search methods. Okay, I mean, just imagine Amazon a few years back. It was just key value pair based search. If you type in kettle, so it will based on your input, it will map keywords with certain amount of products, and it will only portray you that particular. And this does not really works well, right? So you have the data, you ingest the data into a database, and there is a search engine that will just bring you that relevant data based on your search. But this might not be a very suitable use case. When you think about variety or a diverse set of products, right? Imagine even with the hiring tool, right? Candidates with 5 years of experience. Now, this is a more like an NLP use case, right? You present a sentence, and the AI, the search engine should be intelligent enough to extract an information that hey, experience is more than or equal to 5 years, right? In this case, and then based on the OCR inputs from the raw unstructured data, it should be able to map the candidates with experience more than 5 years, right? This does not. This was a challenge with the traditional search method. This was something that was not possible with the traditional search method. Now, when you have AI powered search, first of all, you ingest the huge cost of data. You're continuously, putting in the data that's coming with you. Just think of an HR application, right? And this data is being continuously extracted. There are vector databases that is storing the data. You might also perform some sort of an enrichment. Let me give an example. Now, I could have written um experiences, or experiences as work experiences, internship experiences or internships, something like that, right? You want to perform enrichment as anything that is as an internship experience, job experience, work experience, so on and so every synonym mapped to as an experience. Okay, as simple as experience. Or you want to perform and this is a very simple use case. Just think of an other sort of an enrichment wherein if there are a specific section within your resume, and I'm taking that resume so that you can relate to it. So you have a resume and you have projects mentioned within that, right? Based on this few set of projects, a few set of skills that you mentioned within your technical skills section, if it's web development front end, if it's Go with backend, or Rust with backend, I can club together and form it as a front end or a full stack developer, something like that, right? So this could be some sort of a manipulation on the data. It could be an enrichment. Or give an example, the chatbot feature, right? So the chatbot has some sort of a huge cost of data, and the huge cost of data based on the search engine gets extracted, and then there's a Gen AI model that also recreates a content and presents it into a particular format. Okay, so that is a particular case of enrichment. Now, this enrichment is being performed. It might be stored, or it might be done at a real time based on the specific use cases. And just imagine the user searching a generic question onto the search bar. Based on that query, it will perform that semantic analysis, and it will get you the relevant data in the required format. So this is what AI powered search has transformed the industry with. Okay. When we talk about, I'm putting on that use case of extracting document intelligence, right? Now you very well remember during that call of document intelligence, and I just portrayed it in this example so that you can relate, because we have discussed this in very detail. You remember, right? We had put in a document and it was extracting the title, the paragraph, the images, any graphs, the subsections, the subheaders, so on and so forth, right? Signatures, so on and so forth. Now, every detail is being captured and is being stored in a key value pair. I hope the markers are visible to you. Now, this is being performed by a vision based model, right? Imagine what could be the next step. Then there is a language based model that will analyze the context or the insights that is being presented in this paragraph. I don't want to read a long, research paper or a newsletter. I want to summarize insights. I want to extract the exact insights that's relevant to me. So it will perform this language, will understand the insights. It will capture that is something that's relevant. Okay, and maybe at once you have captured that insight, there is a speech model which will which will summarize which will call out that exact summarized data into a speech form. It will read out that content for me in a summarized form. This is something that use case you can also think about. A lot of other use cases you can build on top of it, so on and so forth, right? Let's dive deeper into it and understand for each of the use cases how things work. So first, let's talk about content search. Now we talked about what is content search, right? Let's directly dive into the technical architecture diagram of how content search works, and this is very important. I want your full attention while I discuss this. This might be a bit overwhelming initially, but this is how the industry plans or designs a solution. And this is something that you should learn if you are seeking for a path on solution architect or an architect role. You should understand these architecture diagrams very well. So that's where I just pulled in. I did not make it conventional demo session, but I just wanted to highlight on how do you get started understanding an architecture diagram or a flow. Okay, and how does the organization plans for these sort of solutions. I'll also add on something. These are a very basic architecture diagram, but I'll show you how what are the other features that we can implement on top of it. Okay. Okay, now you see the content search technical overview. Okay, this eliminates any tedious task of doing content search manually and helps any organizations, employees, VPs to review, huge amount of data in a short span of time, or maybe like a huge set of documents in a very small short span of time. Now you see the unstructured data, the text data is being provided. Now you think of what sort of an unstructured data it could be. It could be anything. It could be doc, it could be PDF, it could be image, it could be any sort of SVG which contains some text data. It could be anything, right? Now this unstructured data, any sort of a document, anything. Okay, now the idea behind is not to think about or limit the document type that can be ingested to this model, but to capture the insights from this particular document, right? That's where we'll have initially an OCR based model or a computer vision based model to first of all classify the type of the document. What is this classification? Why do we need? Now imagine. Yeah. Now imagine you said, right, this is unstructured data. Unstructured data could also be data of a single label, like a government survey of a particular type. It could be also very mixed sort of a data, right? Now I want to understand. I want to classify cluster these data into relevant categories. Something that is confidential data, something that is public data, something that is semi-confidential, or something that can be shared across organizations, so on and so forth. This is for enterprise. Let me give an example of a government. Okay, a government data could be something like this. Again, it could be a confidential and non-confidential, but in the non-confidential category, citizens data, okay, maybe a particular ministry's data, so on and so forth. So anything like that. So first idea is to capture that unstructured data. And unstructured data could be of any format. Classify the type of the data, and again, you'll use a computer vision based model. It will identify the header. Based on the header, it will try to understand what sort of a data it is, and it will cluster the data in a relevant format. Now, once you have clustered the data, you understand that hey, this is a confidential data, this is a public data, this is non-confidential or semi-confidential data that can be shared across organizations. Okay. Now you want to you understand, right? Now these data that are clustered into a particular category would more or less have this similar sort of a structure. It can be a similar sort of structure, but it can also not be a similar sort of structure. But what is importance of classifying this? Now if you think about a government data that is linked to a particular ministry, okay, let's say defense would have some sort of a data similar to total ammunition cost, total cost of procurement of these sort of weapons or so on and so forth. If it's a Ministry of Human and Health, okay. So in that case, it would be some sort of a data on how much people were vaccinated or something like that. So based on the clusters of data that you identified, you will now want to capture the key value pairs. And again, these key value pairs would not be a generic key value pairs, but this is where the semantic part of it again comes in. You will identify the key value pairs. It could be of different the exact words would be different, but the meaning could be same. And you want to map those key value pairs like key 1 to a particular value, okay, and similar key 2 to a particular value, so on and so forth. And you these key 1 and key 2 is something that is important to me. It could be as long as anything, I mean, based on your data, right? And this will be stored in a separate vector database. So this will be stored in a vector database, and you can store it in any database, but vector database are like usually faster for these sort of search AI search engine based queries. Okay, again, there will be another database for this particular data clustered, and similarly you would have another database for this particular data capture. Now imagine these vector databases are created. Now why do you want separate databases? The idea is behind to have separate databases so that you can query them separately. This key value pairs, the key value pairs over here might not be same as the key value pairs over here, or might not be same to the key value pairs here. Now uh, now you have already digitalized the document, because now you're storing it in a key value pairs. And these key value, why do you need this key value pairs? Ideally, querying the value would be the data that you would have probably been mentioned in a handwritten format or in a digital format in the document, right? But this key is something that's important to me. When I have a query, let's say pull in all age data of citizens in my country, so it will pull in the data, or it will query based on the key only. So the age group, and based on the numbers in the age group, it will accumulate and it will provide me the exact insight. If I have to get a value, maybe if I'm making a query, product, get me all the product which are type of kettle. Okay, so it will go to the database, product equals kettle, and it will only get those relevant information to me as an end user's data, something like that. I'm sorry for making it messy, but I hope you are getting that understanding, right? And finally, the search engineering content through knowledge mining. So basically, now you have the data. Based on the key, you will make a search engine to query, and this is where Azure AI Search comes into the picture. Azure, I would not be able to write it well, but I'll make it like this: Azure AI Search. Okay, comes into the picture. This will perform that queries onto the vector database. And finally, there would be an end user who would make a query. Based on that, there would be an NLP based model or semantic search model, which will capture the insight or the exact query. And based on that query, this AI search engine would query the vector database and get you the exact results. Now, when you say the exact results, it could be in sort of a key value pairs in the form of that you want. It could be also the original document that was stored. So in no way you are losing out the document that, or the type of data that you are ingested initially. Okay, It says that on that data we are performing some sort of an operation or manipulation. I hope this was clear. If you have any questions, feel free to ask me directly. And when I would need your help, if there are any questions related to this particular architecture diagram, then we can talk about the next. Okay. Document intelligence extraction. Again, similar to content search, we'll talk about this particular thing as well. This is again, let me share a use case. Imagine, where do you think document intelligence would come into the picture? Think about a greater use case. I mean, you could take up an example of your university maintaining the mark sheet records of students in a hard copy format, and maybe they are uploading the scanned images or scanned PDF formats to an engine. An engine is being storing the data, mapping it with the students' information. Again, this is a one-to-one map. You really don't require, after an OCR, really don't require a search engine to an AI-based search engine to pull out the data. But let's say you also maintain some sort of a records of the students in some other database, which is behavioral records, co-curricular records, so on and so forth. And based on that, the search that you have, okay, let's say I want to get information about a students or a peer, it should not only get the mark sheet data, but it should also get the behavioral records, characteristics records, so on and so forth, and accumulate everything together into an actionable or in a insightful format and present it to it. Okay, that could be a very simple example. You can think of more complex examples. Again, document intelligence is being used widely in domains like, I mean, for computer vision domains, like when you have any government organizations, in terms of some companies performing surveys, or let's say examples of some historic data that is being captured, okay, or being captured in sort of some sort of a image, and then you want to create a digitized format of that document, and you want to, let's say, at a later point in time, you want to retrieve some information out of that document. So those are great use cases wherein you would have document intelligence into the picture. Let me take and show you how document intelligence works into the picture. And again, just comparing, you would a lot of you would have a question about how content search is different from document intelligence. Okay, so we'll discuss that in this. Okay, so again, the data format is the same. Okay, you would have data, unstructured data in any format. Again, this ideally, when you talk about document intelligence, the key thing over here, which is again very not mandatory, but it is similar sort of a data or a similar set of documents for a particular task or a particular use case. In a content search, it could be any document. It could be any document. When I say any document, the type of the document or the extension of the document could be anything. Over here, it could be again anything. But the use case that we are trying to solve in document intelligence should be a singular sort of a use case, a similar sort of a use case. Okay, so now this data in any format, PDF, in image or any other format, can be provided to the end user now, or to the model. Sorry. Okay, now this model would again have an OCR. OCR, I just missed mentioning that. Okay, if it's a structured data, you directly don't need an OCR. You can directly feed it into the model. But if it's unstructured data, a PDF and image, that's where you would again need an OCR based model, a computer vision based model to get the exact information out of it, and then probably you would feed it into this particular part of the model over here. This is something that we'll discuss. Now, what is regulatory obligation identifier? You think, uh, let's give an example. I collected an image or scanned image of a mark sheet document. Now, I want to only capture marks for the cumulative CGPA as well as the 8 semesters, the grades. Okay, something like that. Only specific things within that entire document. Not everything is something that I require. Okay, Now this document is being, I mean, ideally I'm considering that this is in a text format. This is not in a no image format, but it is in a text format. If it's in an image format, basically you'll implement an OCR and then you'll get it in the format of text. Now this Azure function is okay. Do you understand what is Azure function first of all? Imagine it like this. Basically, to run a code, you need a container runtime, right? You need a runtime, I would say, not a container runtime. You need a runtime, and Azure function is a runtime that is available to you, and there is a big implication on why this service is there, and there is a reason for why do we need Azure functions over here. This is kind of a serverless service. Okay, so basically, you're charged for the time that you run that particular code in that runtime environment. And runtime environment could be Python, it could be Go, it could be .NET, it could be Java, it could be any other. Runtime. Okay. So basically, you're having a code that will try to map the key value pairs to what is required, and it's not necessarily key value pairs, it could be also paragraphs. So this will capture the data, the raw data, and it will feed it to a machine learning model. Okay, now this machine learning model would be trained, it would be customized to capture the insights that is required by you, which is your use case. Now, these use cases, the captured insights, will be stored again in sort of a database, and this might not be into a vector database. It might not be into a database vector database because over here you don't require, AI search engine or a semantic search engine. Okay, now this data is being stored in this in any sort of a database. It could be any NoSQL database or so on and so forth. Key value pairs. Okay. Now this key value pairs is being now customized or being presented into a visualized format. It could be in Power BI. It could be in some other format. And then finally the end user sees it. Okay, something like that. So this is a use case of document intelligence, and you can customize. I mean, over here they are using Power BI. You can use any other tool. They basically need. A particular use case that I have mentioned over here is where visualization was required. Okay, it could be also using this key value pair for some other use case, or you want to feed this to a Gen AI model to perform some actions or something like that. Okay, so you can customize the later part of it as per your use case. Till this part it remains the same. Okay, now I'll just mention what is the specific use case. So basically, there was a survey that was being captured. Okay, and the survey had a similar sort of a data. Now the key value pairs that was relevant to us, what we knew about it. So this function basically captured this text from the document. It fed into the machine learning model. Machine learning model was trained to capture that specific key value pairs, store it in a required format, and we did not store it in a database. So it could be as simple as storing it in a text format as well. Okay, or it's storing it in an Excel format. Now this search, basically this Excel data could be then directly fed into a, Power BI tool to visualize that data. Okay, and this was being something that was required to be sent by a management, higher management, or let's say a leadership from that organization. So something like that. I mean, a very generic use case that I presented over here. You can also think about a more greater use case for document intelligence. Any questions as of now? I'll just take a minute break so that people, if you have any questions, you can take up, and then we can talk about the product discovery automation. This is again very important and interesting. Utkarsh says that how does Azure AI Search compares to other search and other knowledge mining platforms? Okay, it's pretty much the concept remains the same. However, when you talk about Azure AI Search, the key difference that people see with AI Search is that think about a diverse data set, right? Or think about a data set that does not have a defined key value format, or it does not have a particular semantic of how or a structured of how the data should be stored. In those use cases, the Azure AI Search works really well. You can also try out Azure AI Search in a variety of other use cases. told you, right? I mean, with the content search use case, you could have multiple form of data for multiple different tasks, and you are performing search based on the user's query. And again, that key values could differ widely. Now you are doing a one-to-one mapping of, hey, if the word is like age, or I mean, sorry, the word is like experience, internships, jobs, or so on and so forth. You club it together into form of a single key pair experience. That is one way. Or you can directly use Azure AI Search, and it is intelligent enough to compare the similar synonyms and club it together and get it you the exact results. That's one benefit of Azure AI Search, and there could be multiple others. Unnati says it's like content management and organization by categorizing and tagging the content, yeah, making it easier to search and retrieve. Yeah, agree to you. Okay, as we don't have any questions in the interest of time, I'll just quickly cover the last part of it, which is product discovery and optimization. Again, I'm making it technical, but I want you to understand this at least on a high level so that you can relate these architectures and then probably think of implementing something of your use cases rather than me just demoing it. It will make much more sense when you think about how you can think about your custom solution. I'm pretty sure you might also have some use cases and you want to think about how you can implement that solution. So I would love to see your architecture diagrams. Plan out before actually implementing a solution. Plan out how your solution should look like. What are the different things that you want to implement within that solution, and then probably get it validated by someone else. You can get it validated by me. Reach out to me on LinkedIn or Instagram, and once you get validated, try implementing that solution. I would really love to see that, and if you need specific help with the implementation part of it, I can also help with that as well. Yeah. Now think about the product discovery optimization technical overview. Okay, taking an example of Amazon. Now you see, there is a variety of data that comes into Amazon. There is reviews, there is product information, there is retailers information, there is product. I would say product descriptions, the product inventory data, how much of the product is there. Okay, there would be specific data. That is from the customer's end, which could be the orders, the total expenditure, or the customer's demography in terms of which category does the customer fall into. And again, all of these informations are being used in some or the other way to get some feature being implemented on Amazon, right? Just give you an example: demography. So based on the demography, Amazon predicts or provides your catalog of services or products that you would attempt to buy, right? Similar to that. So now think of the raw data again being fed into. And again, when I say raw data over here, ideally the raw data when it comes to the models, okay, the AI search model over here, we are using a AI search model. So for knowledge mining. Okay, so the AI search model will ideally use the captured key value pair. So if the data over here we are expecting is ideally either a key value pair, or it could be some sort of unstructured text data. Okay, if it's a key value pair, that's something that's more obvious over here. Now you provide this product inventory data, and there could be multiple phases of data pre-processing that could have been done before actually feeding this to the model. But my insights over here is product inventory. When you talk about it, would have multiple rows of data. It would be it would be a JSON data with multiple branches into it, which would have product title, product description, product rating, product catalog, how much SKU is there, what are the different t-shirt sizes that are available within that product, what is the rating of the product, so on and so forth, right? Now these values, these JSON data will look something like this, multiple data, right? And there could be subcategories, something like this. So it will be a very complex data that you would store over here for each product. Similarly, customer data, right? Customer data would have customer name, orders, customer demography. Orders would have multiple categories. search history, total expenditure, demography, so on and so forth, right? Now, each of these data, a demography is not something that is specific to a particular profile or a customer profile, okay? It would be a cumulative data that is being, captured based on the cumulative users' data or the customers' data. So, based on the age group, it will cluster the data, it will perform a pre processing, it will cluster the data into the variety of age groups, and again, this age groups is something that we'll use by the AI search engine. Now, this AI search engine will be customized to to map these demographics. Just example, taking a demography with a particular product, IT backend, with a particular product that exists, or let's say if there is search history for the user. Based on the search history of the user, it will create a particular catalog that will it will by default recommend on the homepage of the e-commerce platform, something like that. Or you can think about a lot of other use cases. It's a very broad and very dynamic. I mean, I would say it is a much more complex structure that you would form, and there would be a lot of interlinkings. But this is something that Azure AI Search can handle. So this is something that you can think about to this complex level of product inventorying as well as product discovery that the Azure AI Search can do. And once you have these mappings, again, this would be stored in a some sort of vector database. And this could not be a normal database. Obviously, this map linking and this is only possible with the vector database, wherein you have multiple databases and you would have the linking of the key value pairs or the rows with one database to the other, something like that. Okay, and it would be one not one to one mapping. It would be very complex mapping, something like that. Okay, now this is what the AI search do. There would be another engine on top of it, which could be again an AI search engine, or it could be some other customized model, which will map out based on the user's demography, based on the user's purchase history. It will categorize that product group into a particular category, and then within that particular product category it will identify which product to recommend. Maybe within the product category there are tons of 10 of products that are existing, and it will identify which product to recommend based on the rating of that product, and it will finally show it on the homepage of the user. So there will be an additional model over here, which I have not mentioned. And finally, there will be a web server which will be doing the indexing, and the data will be available to the end user on their whatever platform they're accessing. Over here, the diagram that I've presented over here is on the retailer side. So how the retailer would see it. Let's say there is an end user and there are product inventory. This was on the side of the end user. Okay, the end user seeing the Amazon page, while for the dealer, based on the product inventory that are there, and the dealer can support one category type, but dealer can also support multiple category types. Based on the customer data, the dealer and the vector search that has been created over here, the dealer would be able to see how much users are suited for their product of a particular category, something like that. Or what is the expense, or what is the number of orders that have been fetched for a particular product category, so that he can think of investing on that particular product or building on a SKU for that particular product at a given point in time, or at a future, something like that. So I think this gives you a fair understanding of how this works. And you can what I can I'll also suggest one, so you can also check on Gaurav Sen's YouTube channel and just type on product discovery optimization. He really explains it very well. This is a very complex structure, and for you I think it would be much difficult to understand, but do try understanding that video, because that really makes sense of how these complex services or tools are running over the internet. So yeah, this is something that you can really check out, and if you can build something like this, nothing better than that. I can guarantee you that these will really charm your resume to a very great extent. So with this, I come to the end. I did not wanted to make it very technical and overwhelm you guys, but again, I think you got a very fair idea of how knowledge mining works. I would be happy to see some projects on AI search and reach out to me with your queries or how you have been able to use Azure AI Search, not in AI services but AI search for building on some categories of projects, be it on knowledge mining or be it something. Apart from that, you can just go to the knowledge mining. There is some learning model. I'll share the link on the chat as well, which gives you a get started on how you can start on building projects with knowledge mining. There are also a lot of solutions that are that are available on the internet that you can check out some YouTube videos on how you can implement a knowledge mining solution. These are long, these are again a complex projects, but definitely I would encourage you to check out. And that's all for today. Thank you so much for listening to me on a Sunday, that to an afternoon. I'm pretty sure that you had an amazing weekend, and and a great starter for you to work on Monday on a new project. So would be really happy to get connected with each of one of you. This is my Instagram. Um, Profile. You can just scan this QR code, connect with me, reach out to me, and I would be really excited to see what products you are building on top of these AI services that you have learned in these boot camps. So thank you so much for your time, and wish you a happy Sunday ahead.
Thank you so much, Saurav, for an engaging and insightful session. I'm sure everyone here has learned a lot about how powerful Azure AI Search can be in mining knowledge and extracting meaningful insights from data. We truly appreciate you sharing your expertise with us. Before we wrap up,
Hey, thanks, Sunay.
here's a reminder about the top three participants with the best blog or GitHub page for each session will receive premium goodies from Whizlabs and a 1 month Whizlabs subscription for further enhance your AI skills. To qualify for these exciting prizes, make sure to write a blog or maintain a GitHub repository for each session and share your learnings on LinkedIn or X, tagging Azure Developer Community, Whizlabs, and Yash Katyar. Engage actively in the live sessions and follow our social media channels. The deadline for this session submission is Friday, 22nd November 2024, 6 p.m. Make sure to submit before the deadline. In this break before our next session, we encourage you to write a blog or maintain a GitHub repository solving a real life problem using knowledge you have gained from the past 5 sessions. Be creative and use your skills to tackle challenges in natural language processing, computer vision, document intelligence, or generative AI. Submissions will be evaluated, and the best ones will win exciting prizes, including premium goodies and a 6 month WizLab subscription. The winners for the last 2 sessions will be announced along with the winners of this session on 23rd November. Thank you once again for everyone who joined us today. We appreciate your active participation and engagement. A big thank you to the amazing team who works tirelessly behind the scenes to make these sessions possible. We look forward to seeing you all again on 23rd November for our next session on Develop Generative AI Solutions with Azure OpenAI Service. Until then, don't forget to work on your real life problem challenge and keep sharing your learnings. Have a great day and see you soon.